Hi guys, welcome to this tutorial. In our previous lesson, we talked about vector addition and scalar multiplication. And also some fun things we can do around vectors, although we have a lot we can still do with them. So for today, we want to talk about a special case of multiplication, which actually involves multiplying two vectors, but we're not going to get a vector. We're going to get a scalar. So it's called a dot product or a scalar product. So that's what we call it. We call it a dot product or we call it a scalar product of real vectors. Although the principles we are going to make use of here also applies for complex vectors too. But in a real sense, we just have to learn about the real vectors, and you can apply those situations for the complex vectors. But if you have a question, you can always drop it in the comment section, and let's see if you can go around it. Of course, I'll appreciate if you like and subscribe, and in any way you can help fund this video. It's going to be nice. So let's dive in. So our lesson objective is simple. We want to talk about dot product and orthogonal or perpendicular vectors. So orthogonal also means perpendicular. So we're talking about how or the characteristics of a dot product that shows if a vector is orthogonal or perpendicular to it. And you should know that perpendicular means it forms a right angle. So if you remember the first vector, okay, so let me add the previous knowledge to what are vectors. What are vectors? So you should also see these videos. It talks about the graphical demonstration or illustration of a vector. So an orthogonal vector graphically is when the angle between the two vectors is 90 degrees. So if I'm having a 90 degrees angle between the two vectors, I say the vector is orthogonal. But here we are more concerned about the number. So what is the numbers telling us? What can we see from the numbers that shows that this vector is orthogonal? So before then, we define a dot product. So let's define dot product or scalar product, anyone you want to call it. So I can define a dot product, and I can say, suppose I have two vectors u equals to a1, a2 up to an, of course, and I have another vector v. Similarly, I have b1, b2 up to bn. So we have two vectors u and we have vector v. So first, as we all know, we should always check the order of the vector. Do they have the same amount of elements? So u goes from 1 to n, and b also goes from 1 to n. So yeah, we can carry out operations on them. So now let's define the dot product. So the dot product, u represented by u dot v, is the dot product between u and v. Is equals to, I multiply each corresponding elements with each other. So I have a1 times b1 plus a2 times b2 plus on and on up to plus an, then bn. So this is the dot product between the two vectors. I'm multiplying the corresponding elements with each other. And the amazing part of the dot product is that it gives us a scalar. So uv gives a scalar. All the times it gives us a scalar. Now, how to know if our vectors are perpendicular or orthogonal is if the dot product is equals to 0. So if I have the dot product equals to 0, therefore the vectors are orthogonal. If the dot product is equals to 0. So let's take a quick example. So suppose I have u is equals to 1, 2, 3, 4. So example, suppose u is equals to 1, 3, 4, and v is equals to 6, k, minus 8, and 2. So find k so that u and v are perpendicular. So our solution, let's have our solution. So the word perpendicular here, it says is synonymous to orthogonal. And we know if two vectors are orthogonal, then their dot product is equals to 0. That means we can say these two are equals to 0 because this vector is orthogonal. So to find k, we have to find their dot product. That's, we are multiplying the corresponding elements together. So I have 1 times 6 plus 2 times k plus 3 times minus 8 plus 4 times 2, which is equals to what? Equals to 0, because the vectors are perpendicular. So my 1 times 6 will give me 6 plus 2k minus 3 times 8 should give me minus 24, then plus 8 is equals to 0. So let's simplify from this end. I would have 6 plus 8. 6 plus 8 would give me 14. So I will have 2k is equals to 14 minus 14 plus 24. So I'm bringing these values to the other side and the sign is going to change. So I have 2k is equals to 10, which implies that my k is equals to 5. So the value of k that will make this vector perpendicular or orthogonal with each other is 5. K is equals to 5 is the vector. So I want to leave an exercise for you. I would like your answer in the comment section. So I'd like for you to comment your answer. So let u equals to 1, minus 2 and 3. Let v equals to 4, 5, minus 1, and let w equals to 2, 7 and 4. Now my question is, which of these vectors are orthogonal? So which one of them are orthogonal to each other? Of course, you know that if they are orthogonal, if the two vectors are orthogonal, then you have to check each vector with itself. So I have to check u to v, u to w, and so on like that to see if the vectors are orthogonal. Alright, so this comes for this we round up to today's tutorial, and I hope you've learned something. See you in the next tutorial. Don't forget to like and subscribe. Thank you.